We can think of a function as a machine that gives output for some input using a given condition or formula. Here, the formula used is add 3. We can write add 3 as x plus 3, where x denotes the input. We can denote expression x plus 3 as f(x), which means a function f of x. For input -1, output is 2. For input 0.5, output is 3.5. For input 4, output is 7. We can write the function as a set of ordered pairs. Here, in the ordered pairs, the first element is the input and the second element is the output of our function machine. We can represent a function by the mapping between two ovals as shown. Here, the function f is from R to R. Consider a set A and set B, both having elements 1, 2, 3, 4. Let us define a relation from set A to set B as y is equal to x plus 1. Is this relation a function? Let us draw an arrow diagram to show this relation. We see that the element 4 in the left oval is not related to any element of the right oval, so it is not a function from set A to set B. Let us define one more relation from set A to set B as x plus y is greater than 4. Is this relation a function? Let us draw an arrow diagram to show this relation. We see that the elements 2, 3 and 4 of the left oval are related to more than one element of right oval, so it is not a function from set A to set B. A relation f from a set of A to a set B is said to be a function if every element of set A has one and only one image in set B. Let us consider some other relations and discuss whether they are functions. We can strengthen the definition of a function with the help of a birthday function. Every person has a birthday, and one person cannot have two birthdays. The discussed function can be represented on xy coordinate plane as shown. Here, we take x on the x-axis and fx on the y-axis. We can strengthen the understanding of the function with the help of vertical line test. Vertical line test is used to determine whether the given graph represents a function or not. The graph represents a function if a vertical line intersects the graph only at one point. For example, graph of function y is equal to x plus 3 is intersected by vertical lines only at a point. Hence, it is a function. Consider the graphs as shown. These graphs do not represent functions because the vertical line cuts the graph in more than one point. These graphs represent functions because the vertical line cuts the graphs in only one point.
Then a function f from set A to set B is a rule or method that associates the elements of set A to the elements of set B such that all the elements of set A are associated with the elements of set B. An element of set A is associated with a unique element in set B. Function f is the subset of A cross B. For every A belongs to set A, there exists one and only one B belongs to set B, such that AB belongs to F. All functions are relations, but all relations are not functions.
Conventional notation of a function is shown here.
Let A and B be two non-empty sets. Then, a relation f from A to B, that is, a subset of A cross B, with domain A is called a function. If no two different ordered pairs in F have the same first element, each element of A appears in some ordered pairs of F.
Does this relation represent a function? No, this relation does not represent a function as C has two images, 2 and 4.
Let f mapped from A to B be a function from set A to set B. Then set A is known as domain of f. Set B is known as the codomain of f. The set of all the f images of the elements of A is known as the range of f.
Here, f is a function defined from set A to set B. Then, set A is the domain of function f, and set B is the codomain of the function f. Range of a function is a subset of its codomain. Here we find a function from set A to set B, and then we also find its domain, codomain, and range. We observe that the function from set A to set B is defined as fx is equal to x plus 1. Domain and codomain of the function are set A and set B respectively. Range of the function is a subset of its codomain, and it consists of elements 2, 3, 4, and 5. Find codomain and range of the given function. Here set B is the codomain as well as range of the given function. Here we have one more example. Let n be the set of natural numbers and R be the relation on n and is defined as shown here. Find domain, codomain, and range of R. Is this relation a function? Each natural number has a unique image under the given relation, so this relation is a function. Range of this function is the set of even natural numbers.
A function which has either the set of real numbers or one of its subsets as its range is called a real valued function. Real function, a function which has either the set of real numbers or one of its subsets as both its domain and range is called a real function. The domain of the real function fx is the set of all those real numbers for which the expression for fx or the formula for fx assumes real values only. In other words, it is the set of all those real numbers for which fx is meaningful.
Here we find the domain of a real function. The function fx is equal to 1 upon x plus 3, assumes real values for all x except for the values of x satisfying x plus 3 is equal to 0. Hence, domain of f is the set of real numbers except negative 3.
The range of a real function of a real variable is the set of all the real values taken by fx at the points in its domain. Algorithm to find the range of real functions. Put y is equal to fx. Solve the equation y is equal to fx. For x, let x is equal to gy. Find the values of y for which the values of x obtained from x is equal to gy are real and in the domain of f. The set of values